Welcome to Homework Help for Lesson 6, Home on the Range. So our first assigned problem is actually not on the first page, it is on the second, and it's all the way jumping into the set. So determine whether the given information represents an arithmetic or geometric sequence, then write the recursive and the explicit equation for each. So we're going to look at a sequence and determine first, is this arithmetic or geometric? So we got 2, 4, 8, 16. Now, arithmetic sequences will always have the same common difference, right? That'll be like plus 2, plus 3, plus 4, something like that, where it's like adding plus 2, plus 2, plus 2, plus 2. Each step it adds the same, or subtracts the same, but it's the same step each time. In this case, though, we're going from 2 to 4 is a jump of 2, and then we're jumping 4 from 4 to 8, and then we're jumping 8 from 8 to 16. So it seems like we're always doubling. So that is going to tell me that is geometric. So we're just going to circle it, but that's geometric. And now let's write rules for each. So recursive, we're going to have f of n equals f of n minus 1. The previous, something just happened. The previous times 2. And then we also need to say that f of 1, or our first item on the list, is 2. Right? Our first item is 2. And then explicit, we'll change colors for this. We just need to know if we plug in an n, we need to get the right number. So we're definitely going to have 2 as our base, but then the question is, are we going to plug in n plus 1, and minus 1? What are we going to plug in? If we do plug in 1, we should get 2 out. So it's just going to be 2 to the n, right? This is one of the functions or the sequences that we've actually looked at a lot so far this year, right? A lot of the homeworks have had like this same sequence, and so we've sort of revisited it here. On to the next one. So for number 7, all right, time in days. So we're talking about days on the first day, the second day, the third day, the fourth day. There are different numbers of dots. So there's 3 on the first day, 7 on the second, 11 on the third, and 15 on the fourth. So first thing, let's look at the jumps that we are making in our output. So from 3 to 7 is a jump of 4. From 7 to 11 is a jump of 4, right? So this tells me, right, if we see plus 4, and that's consistent when we're using addition, that is arithmetic. So arithmetic sequence. And now let's write some rules for it. So we've got fn. Oh, that's not supposed to happen. F of n equals the previous f of n plus, oops, sorry, not plus 1, it's minus 1, isn't it? The previous step, f of n minus 1. And then all we're going to do is add 4 to it. And we have to take note that f of 1, our first number, was 3. F of 1 equals 3. So we have to take note of that. And then explicit, we're going to change colors again. F of n equals, and now this is a little tricky. We should have, when we plug in 1, we need to get 3, but it's got to be, we're jumping by 4s, right? So it's, oh, that's a bad 4. Hang on, let me rewrite that one. So it should be 4n. And now the question is, what do we have to add or subtract in order for it to be 3 if we plug in 1? So if we plug in 1, we would get 4 times 1, which is 4, but we have to have 3, so we actually need a minus 1 here, right? That way, if we plug in 1, we'll end up getting 3, which we know is our starting point. So that is good to go on the first one. On to the next page. Let's see where we go now. All right, so 8 and 9 are more of the same. 10, here we go. Scott decides to add running to his exercise routine and runs a total of 1 mile in his first week. All right, so Scott is going to start running. he plans to double the number of miles he runs each week. That jumps out to me. Whenever you see double, triple, cut in half, something like that, that tells me that it is it's going to be geometric, but it tells me it's like exponents. It's repeating multiplication. Like if you double and double and double, that's times two times two times two times two. So that tells me if I see double, that is going to be geometric all the way. And let's see, his recursive, let's see, a recursive form would be the number of, you know what, let's change it up. Let's not use F and N. Let's use, well, let's see, it's miles, right? He decides to add running, so the miles and week. Oh, okay, so that's fine. So let's use miles, the number of miles, his output, which is going to be M, based on the number of weeks. So that's going to become W. All right. So we're changing up the sort of what we're using a little bit. We're going to say that the miles based on the weeks, the miles he runs in a given week is equal to the miles he ran of the previous week, or the week minus one. Uh-oh, that's not what I meant. There we go. Minus one. Oh, we're moving things. Hang on. Minus one. And then it's going to double, right? That's what we said. It's going to double. And then we also need to know that the miles he ran in the first week was just one, right? He ran 1 mile the first week. All right. Now explicit, the miles that he runs in a given week is 2, right? 2 to the something. And that's actually going to be 2 to the, like 2 raised to the weeks that he's been going minus 1. Now, why is it minus 1? Well, we don't actually need, let's put the equal sign in here. We could do weeks minus 1, like as his exponent, which is going to be the same. Like if you like writing it like that, you can write it like that. We could also say that he runs 2 to the weeks, right? 2 to the W, right? Miles each week. But the first week, he actually only runs half of 2. So it would be like 1/2 of 2 to the W. So either one of these would be correct. These are both explicit functions that'll work just fine. All right. But those are equivalent. So that's the recursive and the explicit. And all right, we're going on to the next page. Here we go. Oh, no, we're not. Did I miss something? Here we go. Go. Down here, find the indicated outputs. All right, so for number 11, we're using the function 2 to the n, and our first input is 5, which means we need to figure out what is 2 to the 5th. Oh, and it didn't write it there. It's really not writing it. There we go, 2 to the 5th. So besides using our calculator, right, which we could do, we can just do 2 times 2 times 2 times 2 times 2. I think that was 5 of them, but let's write this out. 2 times 2 times 2 times 2 times 2. Okay, that's definitely 5 of them. All right, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. All right, so f of 5 should be 32. All right, let's write that. F of 5 is 32. All right, so we are done with that one. Right, so we just had to know that the n becoming a 5 means we're repeating the multiplication 5 times. All right, now we're moving on. We're still using 2 to the n. I had noticed this. We're still using 2 to the n, so let's write that down first, right? F of n equals 2 to the n. All right, and now we have f of 0. So f of 0 really means we're doing 2 to the 0. So what happens if we take 2 and multiply it by itself 0 times? Or basically we have no 2's multiplied by anything. Well, it's a little tricky, but you can remember that any number, any non-zero number, whether it's positive or negative, when you raise it to the 0, or when you multiply by itself 0 times, it becomes just 1, positive 1. And the reason that makes sense is that it's really like you have 1 times 2 some number of times. But in this case, we have, right, 1 times 2, right, 0 times. So how many 2's are there? Well, there's 0 of them, right? And you can tell right there, there are 0 2's. There are 0 2's. All right, so we just end up with 1. Oh, right? It's the 1 all by itself, all right? So equals 1. It's a little tricky. It's hard because we don't really do any multiplying out. It's just, you just have to remember that a number raised to the 0th power, or raised to a 0 when the exponent is 0, it's just going to become a 1. All right. And is there anything else? There's number 14. All right, this is the last one. It looks just like the previous, but now with a negative sign. So remember that if we have a negative sign in front of exponents, a little reminder that we have PEMDAS down the side, right? Should be a refresher from previous years. Parentheses are first, but the exponents actually come before the multiplication, right? And the multiplication, this minus sign is actually, nope, don't make a note here. This minus sign we actually consider to be multiplication. All right, so the exponent is going to happen first. So what are we going to do here? We're going to say this is negative times 2 to the third. All right, so we have to do negative 2 times 2. Oh, it's not working for me again. Here we go. Negative 2 times 2 times 2. Right? The 2 to the third is what's shown here, and then the negative is what's right here. All right, so it's a one negative sign, and then 2 times 2 times 2. All right, so when we do this, we should get negative 8. That looks like an infinity sign, but kind of sideways. I don't like that. Let's try one more time. Negative 8. There we go. And finally, f of 0, this is negative 2 to the 0. So we repeat the multiplication of the 2 0 times, right? So this is going to be negative, and then the 1, because 2 to the 0 is 1, and then we have that negative sign, so negative 1. Right? And we'll circle both of these, that's fine. All right, you can always circle or square your final answer if you're worried that your work is not the easiest to follow, so I'll circle them, and that will conclude this homework help.